Okay, so we are going to look at section 6.2. This is another option for how to find the volume of one of these 3D revolutions. And so the idea for this one is we're going to use what are called shells, okay? So let's get a picture here so that you understand what's going on. Okay, so here's a shape. We're going to spin this around the y-axis, okay? So let me get kind of another half over here, okay? So, okay, so we've got, let me get this to kind of, let's round this out, okay? Now, so the idea, that looks really bad down there. Okay, so the idea is basically this looks kind of like a bundt pan, okay? If you've ever seen one of those bundt pan, the bundt cakes, they're kind of those rounded tops. They've got the hole in the middle type of thing. Now, the concept is that what we do here is we make a cylinder, okay? And I'm going to kind of draw my cylinder in. Okay, so here is my cylinder. Okay, and this cylinder goes through and around. So this part in here is open. Okay, and it drops through, and basically we stack them. A lot of times you'll see those little like kids toys, okay, and they're these little round cups things, and they come in all different colors, and they stack inside of each other, okay? And that's kind of the idea here is I take these cylinders and they basically stack right on, right around outside of each other, where this one fits in the next one out and the next one out and the next one out. And so basically if I can find the volume of each of the cylinders, okay, then I can find the volume of the overall shape. Now, the concept here is that if I have this cylinder, okay, so I'm going to draw it like this, okay, so it's kind of got a hole in the middle, okay, so let me put this down. So we've got this hole in the middle, okay. If I slice this thing open, okay, I basically have a rectangle, okay. And we know that this measurement, okay, is the one that went around, so that's going to be 2 pi r. We're going to have to figure out what r is, okay. And then this is our height, okay. Now thinking about, kind of the idea that's coming from here, the radius on something like this would be how far out we would be coming to here. The height then is dictated by our function, okay. So let's take a look, okay, at one of these. Now I'm going to take this same shape, okay, and I'm going to switch where my axis of revolution is, okay. So this is, we're going to be looking at the function 3x minus x squared, okay. So we've got here, here, I'm going to wrap this up to here, okay. Now we are going to revolve this thing over here around x equals -1, okay. So let's talk about where all of this, kind of comes from and what this is all going to look like. So thinking about, okay, so that other hump is going to be over here. Thinking about from here, this measurement is going to be our radius, okay? So thinking about coming out over to here, okay? We've got to get, now first off, this is at 0, but that radius right there is 1. So my radius is going to be 1 plus x, whatever my x is, okay? And then my height will be this. So let's think about this. Going back to our picture of our rectangle, we said this bottom edge is 2 pi r, and this was our height, and we said that was our function. So we're looking at 2 pi 1 plus x for that part. And over here, we're looking at 3x minus x squared. Okay? Hopefully that all kind of makes sense. And then basically what we're going to do here is to find the volume. Okay? We would do the integral from a to b, okay, of 2 pi, your radius, so r of x, and then your h of x, so your height function, dx. Okay, so if we were going to worry about this one, okay, the one that we just had that we were talking about, I would have an equation that looks like the integral, okay, let's see, from 1 to 3, of 2 pi 1 plus x times 3x minus x squared dx. Okay. So now I'm going to move up a little bit and we're going to clean that up just a little bit. Okay. So I'm going to pull. Oh, that should have been from 0. I'm sorry. That should have been from 0 to 3. Okay, so I'm going to pull the 2 pi out to the outside from 0 to 3, and then I'm going to FOIL this. So I've got 3x minus x squared plus 3x squared minus x cubed dx. Okay, so I have not done anything other than I FOILed those two functiony parts together. So we've got 2 pi integral from 0 to 3 of 3x plus 2x squared minus x cubed dx. So sending that up, back up. It's going to be 3 halves x squared plus 2/3 x cubed minus 1/4 x to the 4th, and that's going to be evaluated from 0 to 3. Now, if I plug in 0, I'm going to get 0 all the way through. So we've got 2 pi. I'm going to let a calculator help me out here. And I get 11.25. So I would do 22.5 pi. Okay. You could also write that in fraction. So 45 halves pi. Okay, you could do it that way. And so that's kind of what we're looking at when we run these. Okay. So let's take a look at another one. Okay. And again, the trick to any of these volume methods is just making sure that you've got all of your little parts and pieces set correctly. Okay, so we're going to do y equals square root of x, okay, bounded by x-axis and the line x equals 4. We are revolving around the y-axis. Okay, so picture. Okay, so here's our shape. We're spinning this thing around the y-axis. So we're going to have kind of this other shape that goes this way, okay? And again, this is solid and we're spinning this way. So we've got kind of this, it would almost look like a solid cylinder, solid ring all the way around with this kind of V-shaped thing getting pulled out, okay? So let's talk about what one of these cylinders, let me pull a different color here, what one of these cylinders is gonna look like, okay? So let's talk about it. So the radius of this thing is just gonna be X. So R of X is just gonna be X. H of X is going to be our height of our function, okay? So it's gonna be square root of X, okay? So now, we're integrating from 0 to 4, 2 pi, your radius function, and then your height function. Okay. So, again, we're going to pull that 2 pi out, 0 to 4. Now, guys, that is x to the 1/2. So that's going to be x to the 3/2 dx when we put those together. So we're going down. Got 2 pi. So 3/2 is going to go up to 5/2. So I need 2/5 out here on the outside. And again, that's going to be evaluated from 0 to 4. If I plug in 0, I get 0. We see that 0 thing happen a lot. So now I need to worry with, so we're going to do 2 divided by 5 and then 4 raised to the 5/2. Okay. And so I get 2 pi 12.8. So I'll do that times 2 just to clear that up out of the front. So I have 25.6 pi. If you wanted to put it into fraction, we'd have 128 over 5 pi. Okay. Now, personally, sorry, put that down. Personally, for me, cylinders are sometimes harder for me to see, even though the math follows a little more of a geometry background to it, okay? You know, there is not, and the thing is that if all they ever say is to find the volume, you kind of have to take a look at the picture, okay? Certainly if you're making something that is solid all the way through, for example, we've done this one before where we did the square root, but we spun it around the x-axis. That automatically makes it that it is going to be a solid shape, okay? So I would not use cylinders, okay, to do that with, because with the cylinders, I'm only taking that very thin outside shell, okay? If I'm doing solid stuff, then I need to be using something like discs to do that with, okay? If we're doing something now, this could be done, this one could be done using washers because I can see the solid shape around and the open space in the middle. So you could do this with washers. Cylinders can also be used, okay? It's just kind of a personal choice as to how you want to go about looking at how that is done, okay? But again, the key thing here is you're going to need to figure out your radius function and your height function so that you can set this up. And basically the formula that we're using here is surface area for a cylinder, okay? And that is the shell method.